Hi, Year 11. This is our last lesson for the topic of discrete probability distributions. So this is what we've covered. We've learnt about random variables. There's two different types, discrete and continuous. And in this particular topic, we're looking at discrete probability distributions. Then we learnt about expectation and fair games. Now, in addition to the mean of a probability distribution, we can also calculate the variance. And just like with statistics, this is an indicator of the spread of the data values. Here's the formula. The variance of x is equal to the sum of, we take each x value, we subtract the mean, and we square that difference. That's to get rid of the positive or negative sign. Then we multiply that by the respective probabilities. Now there is another formula for variance, and we're just going to go through the proof of that. We're going to start by expanding this out, which gives us x squared take away 2x mu plus mu squared in brackets. Now let's separate this into three separate parts, like this. We'll talk about this one in a minute. See how I've taken the mu out the front because it's independent of x, and the mu squared here. Okay, this part here, it's very similar to x times px, which of course is the mean. But this is e of x squared. Have a look at this part here, that's e of x. And what do you think this is? The sum of all the probabilities, do you remember? That has to be equal to 1. So we're going to end up with e of x squared, take away 2 mu, multiplied by e of x plus, this is 1, mu squared. E of x is mu, so this is take away 2 mu squared plus mu squared, which gives us this. And that's the alternate formula for variance of x. And you were given these on your reference sheet. E of x is equal to mu. The variance of x is equal to e of x take away mu all squared, or e of x squared take away mu squared. Now, just like statistics, the standard deviation of a discrete random variable is the square root of variance. And here's our symbol for standard deviation. So let's look at an example. Calculate the variance and the standard deviation for this probability distribution. We're going to need to start by working out the expected value because we need to subtract that from each x value. So remember how to work that out. We go 0 times 0.15 plus 1 times 0.2 plus 2 times 0.4 plus 3 times 0.2 plus 4 times 0.05, which gives us 1.8. Now I'm just going to add an extra line to this table and subtract 1.8 from each of these x values, like this. So x take away e of x is negative 1.8, negative 0.8, 0.2, 1.2, and 2.2. So in each case I've gone 3 take away 1.8 is 1.2. 4 take away 1.8 is 2.2. Now we're ready to put it into the formula. So remember it's going to be this value here squared multiplied by the respective probability. So this one squared times this squared times this, etc. and add them all up. And that's going to give us 1.16. So that's the variance, and the standard deviation will be the square root of that, which is 1.077. Now the really cool thing is that we can use the stats operations on our calculator to calculate mean and standard deviation. All we have to do is use the frequency column to input the probabilities. Now if you've forgotten how to turn the frequency column on, all we do is go Shift Setup, arrow down, and you will see stats. Go into there and you'll see frequency. And we want to turn the frequency on. Once you've done that, input all your x values into the x column and your probabilities into the frequency column. Then you have to hit AC to get out of that, Shift 1 for stats, and we want 4, VAR. That stands for variance. So we go into there and we have got 2 is the mean, 3 is the standard deviation. Go into each of those in turn. The mean is 1.8. and the standard deviation is 1.077. Okay, let's finish off with a past exam question. A discrete random variable x has the following probability distribution. Part A, find the value of e of x squared. So remember, this is going to be all of the x values squared multiplied by their respective probabilities and add them all up. So it's this, 0.5 squared times 0.12 plus 1.5 squared times 0.18, etc., 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 which gives us 10.37. Part B, hence find the value of the variance of x. So we're going to use this formula from the reference sheet because we just worked that out in Part A. So e of x squared take away mu squared. This part we don't know the expected value of x, so let's work that out. Remember, it is x times the probability and add them all up. So e of x is going to be equal to 2.88. And so our variance is going to be 10.37, we worked that out in Part A, take away mu squared, which gives us 2.08. Okay, that's it for this topic. If you want to continue on with this particular strand, the next topic in this series would be continuous random variables, which is a Year 12 topic.